Okay, so welcome all you guys, and today's session is basically the electronics part and the practical part of yesterday's session. Yesterday's session was completely theoretical, and I just told you about all the basic things which we used and advanced thing also. What was the theory, how the communication works between two receiver to transmitter, everything. Okay, how we are set and uh, so basically, we are going to start today with the practical part. So, starting part I will take, and after this part, the Ajit will take about the V-tail structure of a plane. Okay, he will explain how it works and how to connect all the electronics part and how to connect fuselage to control surfaces and the wing also. Okay, so let me join from my phone also, and give me 1 second. Okay. And one more thing, please, guys, speak. Okay, today's session is completely theoretical, so you have to like ask why is this thing work like this? What is this? You should. Okay, give me 1 second.
Hariom Bhaiya, your mic is off.
Okay. Sorry, guys. Okay, okay. So you guys can speak. Okay, please speak up. And here is some motors. Okay, 1 second. Hello. Am I audible?
Yes, you're audible.
Okay. So here are some uh, uh, BLDC motor, okay, brushless DC motor, and here is brush motor, okay, and here is also a brush motor which you have seen in the fan and in the normal toy cars also, okay. So in this, yeah, here is the connector point, okay. You have to give the power to these 2 points, and it goes inside, and there are this is a shaft, okay. Here is some coils,
here are some coils and they are around a magnet. Okay, and then the shaft goes to the back end, and there are some half rings. Okay, so half rings are situated at this shaft. Okay, they are at here, and these wires goes with a brush. Okay, brush is basically like a connecting point. Okay, which touch to the shaft. Okay, the half rings, and when we give the power, the one ring gets negative points, and one ring gets positive points. So magnetic field created by the coils and the magnet are they are permanent magnet. They repel, and then motor rotates. Okay, basically this is the phenomenon in the brush motor. And in this motor there are some magnets, but in this motor you have some coils, as you can see inside. Okay, inside some coils are there, and they are looped. Okay, and some opposite coils are connected with the one wire, and these opposite coil connected with the one wire, and these opposite wire coil connected with the this wire. Okay, so basically when you have to move, you have to increase the magnetic field of opposite coil, and then decrease the magnetic field of this coil. Then it will start rotating. Okay, and when you have to like rotate at very fast, you have to change the magnetic field of all the coils very fast. Okay, for that purpose we have to use the ESC, and ESC is very essential for high ampere current. Okay, as I told you yesterday. So you have to give around 30 amperes. Okay, to this motor to run 14-inch propeller. Okay, so you have to connect this ESC with this BLDC motor. Okay, so you can connect with anywhere to the anywhere. Okay, you can connect this wire to this, or this wire to this, or this wire to this. You can connect anywhere with anyone. Okay, when you have to switch the polarity, so as you can see, if now I'm connected, and if I switch on the transmitter, and then it will start rotating in one direction. I don't know which direction. Okay, and I want to switch the direction, then I will what I will do, like this red wire and black wire, I will switch the connection between it. Okay, I will remove this wire and remove this wire, and this wire goes here, and this wire goes here. Okay, and it will start rotating at another direction. Okay, so here are two connecting points. One is power supply to this ESC. Okay, and here are some single wires. Okay, so in this single wire, as you can see, here are three wires. One is brown, one is red, and one is yellow. Okay, the yellow one is for the signal, and red wire is for the 5 volt, and brown wire is for negative. Okay, 0 volt or ground, whatever you call. Okay, and here is my receiver FSI 6B. Okay, and I have connected with this at the channel 3. Channel 3 is this one, and I can configure this thing, like I can switch channel 3 from here to here, or here to from here to here. Okay, I can do this. Okay, from this my transmitter setting I can change it, but I am using channel 3 right here, and I have connected channel 3 with my ESC to control this motor. Okay, and this ESC receiver receive signal, and it converts it into PWM signal, pulse wide modulation. Okay, and then this ESC receives it, and then gives the power to the motor accordingly. Okay, as I told you. Okay, now I'm going to connect this battery. This is a LiPo battery, 2200 mAh, and this is a ATC. Okay, as I told you about C characteristic, and this is ATC battery. Okay, and this is 12 volt battery. Okay, 11.7 volt specific. And when I connect the battery, you can see this start blinking, and it creates some beep sound. Okay, and when I connect this the battery, I don't need to give power for, especially power to this receiver. Okay, it directly provided by the ESC to the receiver, okay, by these wires, okay. So this is taking the signal and giving it to the power. So I don't need to connect a separate power to this, okay. And as you can see here, beep sound from coming from this BLDC motor because of resonance, okay. So here is my transmitter, okay. I switch it on. As you can see, this LED turns to solid red, okay. It was blinking starting. In the starting it was blinking, and now it turns solid red. That means it has paired with this transmitter, okay. If I want to do rewinding, I have to connect a, give me one second. Here you can see, here are some B, VCC, CH6, CH5, CH4, CH3, CH2, and PWM CH1. Okay. So B VCC means here are 6 channels, and B VCC means you have to, if you want to do pair with another transmitter, you can connect the upper topmost pin to lower pin, which is ground, and the topmost pin is for the signal. Okay, when you connect it, and it is goes in binding mode. Okay, and you give the power and it goes in the binding mode, and you start your transmitter, and you have from starting your transmitter, before starting your transmitter, you have to press this key and then start your transmitter. As you can see, RX binding is written here, okay. That means this transmitter in the binding mode, okay. It will search for all the a signal coming from receiver, okay. When it connects, it will just turn on, and this LED will switch to the solid red, okay. So let me connect. I have connected ESC with the battery, and so topmost pin is the signal one, and lowermost pin is the ground one, okay. Here is my motor, and I'm going to start my transmitter. Before starting your transmitter, make sure you have set all the switches here and the toggle joysticks to ideal position, okay. If you don't do this in FSI 6, it will create some beep sound, as you can hear, okay. I have to switch this joystick to the at the ideal condition. It will just turn on, and now you can give the throttle. What I'm going to say, okay. Now the sound comes, and then you have to turn your throttle up. I'm not connecting the propeller because it's too risky, okay. You can see this thing, and Ajit, do you want to add anything in this part? Then I will connect the servos.
Not anything right now. You can tell them how the signal transfers from the receiver to the ESC and all the PWM things.
Okay, because I don't have my writing pad with me, so I cannot write anything.
Yeah, that's fine. Go ahead now for now.
Okay. Guys, do you have any doubts? You can ask. Then I will move to the servo part. guys, this is not just a movie session.
Hell. Okay, let me continue. So let me show you some receiver and transmitter signals. One second. SI6.
Yeah, while Hariom Bhaiya is searching for receivers, I wanted to tell you something. If you guys are into this hobby and wanted to purchase like transmitters and receivers for your hobby, I would like to suggest you to not go for these kinds of receivers. Actually, I too also bought the cheapest transmitter and receiver that was available at that time, but those receivers and transmitters are not open source, so in future you will not be able to upgrade them. Like there are some receivers, ELRS receivers, which are open source, so they have a separate module attached to them. So whenever you feel like it that you are not having enough power or you want to go further, you can increase the power of your transmitter but just by changing the transmitter module on the back of the receiver. So yeah, that's just it.
Okay, so let me share my screen. I will tell you how PWM signal looks like. So here are some pictures of PWM signal. Basically, this is a square wave. Okay, uh, let me. Is there any whiteboard? Whiteboard कहाँ से आता है? Okay, leave. So as you can see, here are some square wave from 0 volt to 5 volt. Okay, this is my 0 volt and there is my 5 volt. So this is a square wave from this is my 0 volt and this is my 5 volt in these ESC. Okay, and in another square wave you can change it to divolt, 2.5 volt to 3.5 volt as your wish. Okay, but here we use 5 volt, 0 to 5 volt gap amplitude. Okay, and here are two things. Okay, first thing is duty cycle. How much time signal stays at 5 volt in one duration time. Okay, so this starting from here up to here, this is my duty cycle. Okay, sorry, duration cycle, duration time. Okay, and as you can see here is my another duration time and this is my another duration time, so second duration time. So in this duration time there are some duty cycle. Duty cycle means how much time signal stays at 5 volt. If we reduce it, the value will decrease, and if we increase it, the value will increase. Okay, how we configure it? Okay, so basically, um, 8 bit. Yeah. So this is 8-bit signal. Okay. So these are microcontrollers are at the 8-bit. Okay. So 8-bit you have to like your bitwise. If you see the bitwise, so basically it will give you signal between 0 to 255. Okay. And the voltage, I mean duty cycle will okay. If we reduce the duty cycle, the value will tend to the 0. Okay. If we increase the duty cycle, the value will tend to the uh, at the 255. Okay. 255 के आसपास वैल्यू टेंड करेगी. That means you are giving 5 volt. Okay. So I have a pen and paper. No, it's not visible. Okay. So that means if we reduce the duty cycle, it will reduce that PWM signal value. It will tend to the 0, and it will the voltage value will tend to the 0. Okay. If we increase the duty cycle, your PWM value will increase to up to 255, and your voltage will increase to 555 5 volts. Sorry. Okay. So this is the PWM signal, and this transmitter gives this type of signal to ESC, and ES according this value, the voltage value, ESC control this BLDC motor by giving the current to these three wires to generate opposing magnetic field to rotate our outer part of this motor. Okay. And as you can see, the in these motors the outer part rotates, in this motor the inner part rotates. Okay. So these are some things which I wanted to tell you about the PWM signal. That part Ajit will tell you. Okay. Let me stop my screen. Okay, if you want to connect some servos, uh, I have some servos. One second. One second. Here is one servo. Okay. As I told you yesterday, you give PWM signal. Okay. And it will rotate between 0 degree to 180 degree, because this servo is configured like that. Okay. 0 to 180 degree. Okay, there are three types of several type of servo motors. One is 90 degree, one is 180 degree, one is 360 degree, so which can rotate completely 360 rotation. And this motor is made for 180 degree. Okay, and I'm going to connect this thing at my channel A, and as you can see, here are three wires. Okay, one is yellow one, the middle one is red one, and the third one is the brown one. Brown one is for the ground, and middle one, red one is for the 5 volt, and the yellow one is for signal. Okay, PWM signal, which given by this receiver. Okay, I'm connected it at channel 1. Okay, and I'm giving power to the motor receiver. So power comes from this battery to ESC, and from ESC it given to this receiver, and from receiver it comes to the servo motor. So you don't, if you are using so many servos, you might need some extra power to connect. Okay, to control this thing. Am I right, Asjad?
Yeah, yeah.
Okay. So now I'm switching this transmitter. So as you can see, it rotated at some degree, and so this is my throttle. Okay, and here is my servo, and this is my channel 2, and this is my channel 1. and this is my channel 3, and this is my channel 4. Okay, and I have set it channel 5 at this point and channel 6 at this point. Okay, here are some switch also in this transmitter, and these are some knobs, potentiometer to control things. There are, and this is a 3 points toggle switch, and this a fail switch. Okay, let's suppose you are flying your plane and you don't know how to control it. Just switch this toggle switch, and it will uh, like control your plane in it will set a throttle at some value, and it will set your rudder at some angle, so your plane will rotate, make some circles. Okay, and it will come down and okay. So I have set it my servo at channel 1. Okay, this is my channel 1, as you can see. And so here you can control and you can trim it, this thing also. Here are some trim points. You can press these switches. You can see this servo is rotating. Basically, let's suppose you have connected this servo in your plane and you want some slight uh, deviation in rudder so that your plane stays at that direction. Okay, let's suppose you are using so much power in your motor. Okay, and it will give you some torque. Okay, that torque will turn your plane at some direction, so you have to counter that thing. So you have to set your rudder at a particular angle. Okay, so from that thing you can set that thing from here, or you can set channel 1 from here, and channel 2 from here, and channel 3 from here, and channel 4 sorry, channel 3 from here, channel 4 from here. Okay, and you can set this thing from setting also from this uh, FSI 6 transmitter also. Okay, so basically you want to connect some control surface at the end of the pure plane, and you set this servo in the middle and at the end of also. So you just connect it and connect a little thin wire or thin rod with your control surface, and just place it. Okay, with the glue gun or anything which you have. You can use double stick also, but it will break. Okay. Then you can see this servo motor is rotating. Okay, I connect one rod from here to control surface. Okay, this line, and I move my toggle to this joystick to this side, and it will move to this side. Okay, then it will pull the string to the fuselage side, and then your control surface will turn to this side. Okay, and if you want to move that control surface to other side, you have to turn this thing to other side. Then your servo motor will move to the backward, and then it will push the rod, and your control surface will move to the other direction. Okay, and you can adjust those zero level points from here, and from tight before tightening you can set those part from some allen key and some uh, bolts also. There are some bolts with this thing, I will tell you. Okay, any doubt or anything you want to ask? And Ajat, do you want to add anything?
No, not right now. I can answer the question. One person has asked, tell us something about AI drones and how can you use our drone using Python or C++. The thing is, if you want to control your drone using AI, and use machine learning on your drone. First of all, you have to use a SBC, a single board computer, which is there are multiple options available right now, from Raspberry Pis to Banana Pis, and some powerful options also are available like NVIDIA's Jetson Nano modules. So what you will have to do is, there is a something called ROS. ROS operating systems. It's a robot operating systems. Basically, it is a set of software libraries and tools that will help you to build a robot, that will help you to build robots from anything, a simple rover to a drone. ROS works on nodes. Basically, you can install ROS on multiple devices. They will communicate with each other, and you can implement. They have three made libraries for OpenCV and AI models like YOLO version 8, etc. So you can implement those functions in your drone using ROS. It's a robot operating system. Okay, now you can go ahead.
Any other person have any doubt? You can ask, guys. It's an open session. No one? Are you guys taking this excellent? Okay. So I think this thing will not fit here. Okay. So I have some RC plane fuselage. I will show you guys. So one second. So here are some RC plane fuselage. Okay. And this is a control surface rudder. As you can see, this thing can turn in both direction. Okay, this thing is now at this direction, and it will air will come and hit this thing, and it will shift this plane to this direction. Okay, at the right side, and if you switch it to this direction, air will come and hit at this part, and it will turn the plane to the this direction. Okay, and this is the rudder. Okay, and this is elevator, I guess. Is it, am I right?
Yeah, yeah, that's the
Okay,
elevator.
okay. I am so confused in elevator and aileron.
Yeah, ailerons are the ones which are on the main wings.
Okay, I am really confused between these things. Okay, so here is aileron, and
No, no,
you can.
elevators.
Oh, sorry, sorry, elevator. Okay, and this is complete fuselage made by what is the material? I don't remember the name of this material. I forget.
It could be a foam board or a Debron.
Debron. Okay, this is Debron. Okay, you can use foam also.
You guys can
Okay.
even use cardboard.
Yeah, yeah.
That's not a requirement that you will have to use a Debron. Debron is actually a what can I say? A denser version of thermocol. So it's a little more uh, heavier than thermocol, but it has some good strength. So, but if you want to use cardboard, you can go with cardboard, but your plane will be a little more on a heavier side.
Okay. So this fuselage is made by a kit using a kit. Okay. There was a kit around 10 to 15K, I guess. And there was a workshop at this place, and they teach us how to build a RC plane, and they provided this kit, and we made this plane via kit. So there was all the instruction were given, and there was the cut were already made. So you have to just take the paper cutter, and you have to make some small cuts, and you have to connect all those parts. Okay, so this is a main body fuselage. Okay, so here I have used a cycle spoke to penetrate this fuselage to connect my wings. I will tell you how I connected the wing. Okay, and here is also I have used some cycle spoke to connect my landing gear. Okay, so in RC plane there is no system to like attach and detach, like attach and detach the landing gear in mid flight. Okay, so this is a landing gear. Okay, you, if you don't have landing gear, don't worry, you use some something which can roll at the landing point. Okay, so it just connects at this point with rubber bands. We use rubber bands because they are so flexible and so cheap, and you can use glue gun also, and you can connect this thing at here. And the main controller part is here, the receiver, and the control surface part are here, as you can see. This is not visible. Okay, yeah, there you can see the servo are mounted by using glue gun. Okay, and you have to connect those servo, and there are some metal strings going from here to here. Okay, here is a metal string which is connected with this wooden part. This is a balsa wood. Okay, that is very excellent wood in this RC plane. Okay, it's very light and very strong also. Okay, and the other servo is mounted right here, and its string goes from here to at the end of this elevator. Okay, uh, here is the string, and which is connected with this wooden part. Okay, balsa wood part, and you connect the receiver with the channel 2 and channel 1 to these surfaces however you want. So the in this channel 1 is this one. Okay, channel 2 is this thing. So you want to like configure the connection like this key. When you move this joystick to upward, so your plane should go to the upward. Okay, so for that purpose you have to connect this elevator with the channel 2. Okay, so that when you move this joystick to upward, it move to this part so that your plane get lifts. Okay, and when you move joystick to the downward, and it will move to the down, and it creates some drag, and it will create some lift, and but it will turn your plane to the this part. Okay, like this. Okay, so for channel 1 you can connect with the elevator, or channel 2 the rudder part, because this one is channel 2. Sorry, this one is channel 1. You can connect rudder from this because you want to rotate by using the rudder surface. Okay, so you have to connect channel 1 with the rudder. Okay, and then this motor is connected with the ch3, I have told you, and this motor just mounts at starting of your plane, and everything goes behind in this fuselage and connect with the servos, and it is ready to flight. But main thing is missing, the wing. Okay, so I have another body, this is a broken one, so I have another body which is completed. Okay. How I can show it? Okay, the wingspan of this plane is 1 meter. Okay, so this is its wing. Okay, and I have used cycle spoke this fuselage part, and I have used rubber band to tie these things. Okay, I can use glue gun also, but your wing sometimes you have to move this plane to another place where you live, so make it detachable. Okay, and here is another cycle spoke. I have just connected all the rubber bands from here to here, here to here. Okay. These rubber bands are mostly for rotation part and these thing are for the, so that you when you fly this thing, your wing remains with your fuselage, don't get apart. Okay. So here is your control surface. Okay, and here is the rudder, and this is the elevator. Okay, and here is the string, metal strings, which are connect going from here to under the wing. Okay, I can show you. Here is some kind of door under the fuselage, under the wing. Okay, here you can see the metal string connected with the servos. Okay, and these things are connected with the receiver and with the ESC and battery. You place inside, and we are ready to fly. But before ready to going to fly, you have to try uh, in simulators. So Ajit will tell you how to use simulators. Okay, Ajit, do you have?
You can tell them about how to balance the plane first.
Yeah, yeah, CG, the CG part, okay.
Yeah,
The main thing, okay.
please tell them
So,
about the CG.
yeah, yeah, okay. So, first, mount everything like this battery, okay, and this motor also, and all the parts, okay. Just place everything at
Sir,
the
the things
its
you are
place.
showing is not visible in your YouTube live stream.
Oh, okay. Diksha, can you check? Please check and let me know, okay. So we place everything at its place, like battery is placed at here and your motor is placed at here. Okay, and then you have to connect everything. And when your plane is ready, then you have to connect, check your CG, center of gravity. Okay, and center of mass also. Okay, so let me place my phone like okay. So just lift this thing like this, and as you can see, so there is a aluminum rod, okay, to support the wing, okay, as you can see, and just place your fingers at that part because that is the connecting point of your wing, okay, major load part, okay, where it lifts the your wing, okay.
Basically, you can say that your center of gravity should be at 20 to 25% of your wing chord, which is
Yeah,
the
yeah,
breadth of your wing.
yeah, yeah. Okay, so this is the breadth of your vein, and at the starting part, your CG must lie at starting part. Okay,
At
as I told
20
you.
to 25% of the
Yeah.
length.
Okay, from starting 20 to 25 length, your 25% length, your CG must lie at that part. Okay, you place your fingers right under that area, and okay. So my CG is not balanced, okay, because my motor is here, okay. And I connect this thing, and my CG will come at the right point. And if it's not at the right point, you have to add some weight, or you can shift your wing towards backward or forward to adjust the CG, okay. So just put two fingers at that part and try to balance this thing. If it balance, then your CG is correct and you are ready to fly. Okay. Arjun, do you want to add anything? Uh,
Yeah, that's it. You can say that if your plane is not balancing well, you can move your battery forward or backward.
Yeah, so you can add some weight also, but there is major weight of electronics is battery, so you can adjust the battery at from start from like before your wing to after your wing, so you can adjust that thing, move backward or forward your battery, so adjust the CG of your plane. Okay. Okay, let me check. Diksha, can you call Sagar bhaiya or Pankaj bhaiya?
Yes, yes, I text them already.
Okay. Okay. So this is it, and if you have any doubt, you can ask now. And now Ajat will tell you all about his detailed design and his flight controllers. Okay. Speak, guys. If you have any doubt, you can ask. What's the full form of CG? Okay. Ajit, start your part. And
Yeah, okay, sure. So I will tell you about the connections if you are using flight controllers to control your plane. So let me present my screen first.
so at the end, we will discuss where to buy all the parts and how to buy all the parts, what will be the pricing, and which electronic part are best for your beginning starting journey. Okay.
Is the image visible right now?
No, it's all the white. It's completely white.
Can you see the diagram?
No, I'm not able to see. Like, it's just white screen.
Okay, just a second. Yeah, it should be visible now.
Yeah, it's visible.
Yeah, okay. So basically, if we are using a flight controller like a Pixoc or a Matic flight controller, the connections are pretty much same as the one Bhaiya showed before. Just we have to put our flight controller in between all the connections. First, the battery gets connected through a power module. A power module is something which measures the current draw and the battery voltage. So it can tell the flight controller what is the current draw and at what battery voltage we are at right now, so that it can calculate and gives us give us the live feedback. So after that, it's connected with the ESCs and then goes to the motor. The ESC PWM wire gets connected to the flight controller, and the servos PWM wires also gets connected to the flight controller. There is something in the left side, you can see it's a receiver. What it does is it receives the signal from the RC transmitter, and gives it to the flight controller. Then flight controller processes it with the gyro sensors and all the data, and then controls the servo motors, in turn controlling the flight surfaces to control our plane. In the right side, you can see there is another transmitter module. It's an optional module. Basically, it is used for ground station telemetry data. If you want to use your plane for automatic missions, yeah, you can attach this module. This will then there will be another receiver module which will be connected to your computer or your mobile phone, where you can see the plane's activity live on your map. You can adjust the plane's altitude, speed, etc. Through this module by sending commands to it. That's basically it for the connecting diagrams. Let me show you some let me show you some tips about how you can build your own wings without buying a expensive kit or something, like using cardboard. As you can see, this is made up of Dapron. Dapron is a thermocol sheet. Basically, it's a thermocol sheet, but it's a little bit denser than thermocol. So, but what I will say is that Dapron is a pretty lightweight, and but it's pretty brittle also. If you bend it, it will break too easily. So to overcome that, what you will have to do is laminate it with a simple plain sellotape. So after laminating it, as you can see, if I bend this, this will not break. It will just bend. And for the wings, what I did is just used a large Dapron sheet, and then after measuring the wing chord, like this is the wing chord, it's 6 inches. And then after giving a 1 inch or 1.5 inch freedom, you can add another strips and then fold whole plane. And then this is the this is the wing you will get. You can see there is a hole between in this part. Actually, this is a two-part wing. So this is the another part. So both of these gets attached. Give me a second. Like this. Both of these get attached like this, and there is a carbon fiber. There is a carbon fiber rod. This is a 12 rod, which we can insert it here like this, and the another half goes like this, and both of these wings get joined together, and pretty much you can attach this to your fuselage and then fly your plane. For the servos, as you can see, servos are attached right here with hot glue, and there is a 3D printed part here which is for the ailerons, but you can use a simple ID card plastics to build this. This will also work fine. So this is a metal rod. You can get it anywhere in hardware stores and bend it like this, so that whenever the servo moves, you can see it moves the control surfaces up and down to control your plane. Yeah. So my plane has a V-tail design. So this is a V-tail design. It's a pusher design. As you can see, it pushes the plane forward, and then here's the part where the wing gets attached. There are another thin carbon fiber rods attached here to attach the wing using rubber bands, and this is whole fuselage. There is a GPS attached right here. As I was telling you, there is a GPS right here, and then what it does is it gives the coordinates of the GPS to the flight controller. The flight controller records every point of the flight controller records the home coordinates and then flies. If your signal gets lost, what your flight controller can do is actually return back to your home position without any guidance. So it can do that. That's pretty cool. And you can plan your automatic missions with this. So you don't have to control your plane all the way around. You can plan your own missions and then it will do it automatically. Uh, I used to mount a camera right here, but I am experimenting with something else. So there is a mobile PCB attached right now. So let me show you how you can. Let me first let me, show you how you can interact with the mission planner software. Is the Just give me a second. Stop saying. Yeah, yeah, you can see this is the software from which you can program your flight controllers, and you can use it to, like, if you are using a telemetry module, then you can use it to get real-time data from your plane to this software, and you can also program your flight controller to do autonomous missions with this. Let me attach the flight controller. It takes like 15 to 30 seconds. After adjusting the COM port, you can connect from here. It gets all the parameters from the board. I think I have to close it first. Just give me a second. Yeah, as you can see, we are getting all the data right now. There is the altitude, the ground speed, and everything. You can see at the top left corner, the gyros are working perfectly fine. As I'm tilting the flight controller, the gyros also tilts back and forth.
Ajay, you can turn on your camera also.
Yeah, just a second. Yeah, is this visible? This is the flight
Yeah,
controller.
yeah.
So where is the, yeah. So as you can see, I'm tilting it up and down. It's moving right there. Actually, the gyroscope gives the data, takes the data from the flight controller and gives it to the mission planner software. So actually right now it's connected using a USB cable. Okay. So it's only for doing all the basic tasks, like uploading your software firmware to the mission planner, and then doing the calibration and configuring your drones. Like, there is a setup tab right here. You can see there is the calibrate your axle, compass, and then radios. You can also edit your servo outputs, etc. And then there is also advanced hardwares where you can attach your gimbal to stabilize your cameras. There is also fail safe options, like you can see here. Whenever your radio gets disconnected, your plane will automatically turn back to home. You can set it. You can also set it to a battery level. Like, just say if your battery level drops from like 10 volts, then it will trigger a fail safe and it will return back to its home location. There are multiple options right here to change different settings. And then there is a planning tab where you can plan your missions. You can add waypoints from here, and then, like, this waypoint one, then we can, like, right now the GPS is not connected to it, so it's not showing any location in the map. But if we add a GPS, and then it will show its current location, and then you can add waypoints. You can set arc radius, altitude radius. Here you can see this is the altitude. You can set altitude and everything all. So that's it for the setup if you are using a flight controller. Basically, there are multiple videos available on the internet. You can watch them and then view. Hey, stop presenting. View. You can get help from them. And if I'd like to show you the video part, these are the two video transmitters and receivers. This one is the transmitter and this one is a receiver. What it does is it takes the video from the camera and then transmits via these antennas, and then this one receives it. You can attach it with a USB cable to your phone and get the live feed from this. These ones are actually analog video transmitters. They are pretty cheap, so you can use these for your first flight, or you can just fly around. And for
Ajit,
yeah, I wanted to say from you can first start flight with flight simulators, right? If you want to fly your plane, first you should practice with flight simulators. There are multiple flight simulators available. The most famous one is this real flight simulator. Can you see this? Yeah, this is a flight simulator. You have to get a transmitter, and then via simulator cable you can connect your transmitter via USB stick to this software, and then you can fly your own plane. All the physics and everything are pretty good, so you can fly from planes to drones for practicing your flight skills using this real flight simulator. So I think that's everything. If you have anything to ask, you can please tell me.
Ajit, you can tell the cost of all the things you have used. Like,
Yeah, for the cost, the Pixoc flight controller that comes right now comes around like 10K, but there are cheaper options available like Maytech flight controller, which will cost you around 4 to 5K, but it will only work for planes. So if you want to buy something that can work both with planes and drones, you can buy a Pixoc flight controller. There is also something called Pixoc Mini, which is just same thing but in a smaller size, have fewer ports, but it will work just fine. It will cost you around 5 to 6K. You can also go with an APM flight controller, but I would not recommend you to go with an APM flight controller because they are currently, just a second, this is a APM flight controller and this one is a Pixoc flight controller. As you can see the size difference, not too big, but the APM ones are currently discontinued, so the support for this is discontinued. Even if you are using it with your mission planner software, you will have to like go with the older version of the software, and you can not do advanced features with these. Like if you want to make a plane that can do vertical takeoffs and landings, you will have to go with this. You can also let me show you a mini Pixar flight controller. Just a second. This is a mini Pix. I don't know why it's, yeah, here is it. Yeah, it's out of stock right now. I was just saying it's 6K. It's a mini Pix flight controller. It works just same as this Pixar flight controller, but it has fewer channels. But everything that can be done with this, you can use that also. So that's that. And let me tell you the rest of the cost. These are the video transmitters and receivers. These cost around 2K, I guess. Yeah, 2K. 2K for this, 2K for this, both 4,000. And then for the motors, if you are building your first plane, I would recommend you to go with smaller motors and build a smaller plane. So I'm using these motors. They cost around 1500 rupees. And then another, this is the ESC that goes with this motor. This cost around 700 rupees. But if you are building your first plane, I would not recommend you to use these motors because they are pretty big and they are used for larger planes. But if you are making a plane like for 1 meter wingspan, that you can go with the, let me, I have this also. You can go with this setup. This is a 1000 kV PLDC motor with 10-inch prop and a simple 30 amp ESC. This goes around 700 rupees for both of them. Like the ESC and the motor, you can get around like 7 to 800 rupees. I think you can get this whole setup. And then for the radio transmitters, these one costs around 4000 to 5000 rupees. But if you are serious for this hobby, like you want to pursue this hobby for a long time, I would not recommend you to go with these flight control these transmitters, because the transmitter module are inside and these are not open source. Like this is a fly sky transmitter, the company makes its own firmware and you cannot do anything with this. So if you want to purchase your first transmitter, I would recommend you to go with transmitters with ELRS. What is ELRS? ELRS is a open source transmitter module with just the transmitter will be like this. There will be a bay right here where you will have to attach your transmitter module. And if you want to upgrade it, you can just remove the older one and put a new one. Those don't cost a lot, so those are good. And then this is the receiver. So both of these will cost you around 5 to 6k. But for the ELRS ones, it can go up to 10, it starts with 10k and can go up to 15 to 20k. You can go with the lighter version of that, but I would not recommend you to buy these if you are trying to pursue this as a hobby for a long time, because they have pretty limited range also. Like in ELRS modules, they can go up to 5 to 10 kilometers, but these can only go up to 1 kilometers of range. So that's that. And this is the whole plane. The GPS here is like 1700 rupees. It's an M8 GPS. There are newer versions available, M10 GPS, which will cost you around 2000 rupees. You can get that. This is the power module that I was talking about. The wires from this power module goes to the flight controller, which tells the flight controller about the battery, about the current and the voltage that is remaining. Here are the metal gear servos, which is used to as this is a V-tail design. So the elevator and the rudder both are combined in these two control surface. There are two control surface, as you can see. So both elevators and rudders are the mix of these. So like if you want to use the rudder, one goes up and another one goes down, forcing the plane to go this or this way. But if you want to use this as an elevator, both of these goes down to make the plane nose down, and then plane will go down. If I want to take the plane up, both of these will go up and then forcing the plane to go like this, and it will go up. So the servo motors will not cost you much. It starts with 200 rupees and the metal gear ones cost you around 3 to 350 rupees each. And then this is the carbon rod which I was using in between my plane swing to give it a good strength and then to attach my both halves. But if you do not want to use a carbon fiber rod, I would recommend you to just build a wing with a single wing, not a detachable split wing. So you can to strengthen it, you can use from metal rods or anything like that. And then this is the battery. You can also purchase lipo batteries if you want to use those batteries with a drone also, because lipo batteries can give you a lot more current in small amounts of times, but these ones cannot do that. So if you want to build a drone, I would recommend you to go with a lipo battery. Those can be used with a plane also, but if you are going with lithium ion batteries, there are some batteries that are pre-made, but if you want to save your money, you can make your own lithium ion batteries. These are made with four cells, four small cells. These are Samsung cells. One cell will cost you around 350 rupees. So you can calculate for four of these how much you'll have to pay. uh, yeah, for motors, like this motor can only go up to 3s batteries, like 12 volts, but these motors can go up to 6s batteries, okay, like 21 volts, like double of that. So you will get double the rpm, and even more thrust force can be generated with these motors. There are various kinds of motors available. You will have to choose what you want, and let me show you a simple online calculator you can use to calculate your dimensions and other things. Just give me a second. Ombaya, if you want to add something, you can tell them. I'm opening the websites.
No, no, it's all fine. And if you are like in a starting beginning part, you should use simulators because I don't have the cable to connect these things with the simulator. I tried to fly it and I crashed the plane very badly. It split it in half. Okay, and fortunately there was no someone in the range of that crash, so no one was injured. But be cautious about it and please use simulator before flying. Okay, and you can build your own transmitter receiver module with the Arduino if you want. Okay, they can go up to 1 kilometer range also. Okay, but you have to understand the programming and you have to configure these things. Okay, there are some nrf l01 modules you can use, or if you are building something very small like to fly in a range of 10 meters. Okay, like indoor. Okay, so you can use esp also, but there are some slight lag. Okay, you need good internet speed, and because it will controlled by the bluetooth or wi-fi. Okay, there are some bluetooth module also to control these things, so you can buy those things also. But check your requirement, check your like you are passionate about it, you are pursuing it for a longer period, so go with Ajat brother. If you are you want to learn electronics like from scratch, how to build, how to connect, you can come with me. Just kidding. Okay, so you can build from scratch also, and you can buy things also. Okay.
Yeah,
Yeah, so
okay. There are some online calculators available to calculate your, first of all, CG of your wing. As you can see, you can give your wingspan here, then root chord here, and tip chord. Tip chord is the length of the tip, and the root chord is the length of the middle area. But for our wings, both will be same, and there will be no sweep. You can choose for multiple options, like for beginners it's 15%, all rounder is 20%, for experts is 25%. What it will be do is that if you select 25%, your plane will have a characteristics of a, like a jet or something like that. So but if you are a beginner, you can choose this 15% option, and then after you hit calculate, it will give you your wing area, and then Mach distance, which is the distance from the tip to the point where your wing should be balanced. Like uh, you'll have to put your fingertips on both of these sides and then balance your whole plane, so that your plane can fly without any hassle. Now there is a pretty good online calculator called eCal, where you can uh, calculate your how much thrust will be required for your plane, and then what is the wing loading of your plane, and what is the stall speed of your plane. Basically, a stall speed is the minimum speed at which your plane can fly. After that, your plane will just dive down to the ground. So you have to maintain that speed, otherwise your plane will not fly properly. So let me show you how you can calculate it. You just have to put your weight of the plane and then the number of motors you are using. Then you can tell them your wingspan, which is for my plane is 1400. And then you have to give this wing area in meters, decimeter square. Like if your wing area is like, uh, let's just say, if your wing area is 1500 meters square, you can just type 15, and then you can change your air temperature and pressure. I would like you to just leave it at as default. Then you will have to select a battery, anything will just fine. Then number of cells your battery has, mine is 4 cell. And then controller type is the ESC, so I'm using a 40 amp ESC. And then the motor, you get, there are different brands available. For now, let me just select any random brand. Yeah, just 960 kV motor, and then I'll select a 10-inch 4.7-inch propeller. So I'll hit calculate. So there are different things you can see in the data. First of all, at the right side, you have the wing loading of your plane, which is 100 gram per meter cube. And then after, the most important thing, it's the stall speed, which is right now it's too high for our RC plane, but I'm just putting random values, so doesn't matter right now. So it's showing us 48 kilometers per hour. So it's the minimum speed required for our plane to fly properly. So if we go below that, our plane will just stall, which that is just nose dive to the ground. So and then the propeller, according to the propeller which we are using, which is 10 inch and 4.7-inch pitch, it will give us a rough estimate about the speed, maximum speed that our plane can reach, which is 82 kilometers per hour. But keep in mind that these speeds are, and the stall speeds, these all things are just theoretical. In real life situations, these are much different, but it can give you a rough estimate and rough idea about your plane. So for example, the estimated speed that it's showing right now, which is 82 kilometers hour, it is too much. At max, the your plane, if you are making a 1 meter wingspan plane, it will go like 60 to 65 kilometers per hour for max speed. And if your wing characteristics and everything is fine, your stall speed will lie around 35 to 40, 30 to 40 kilometers per hour. So you'll have to fly at 50 kilometers per hour. That means your cruising speed will be 40 kilometers per hour. So anything anyone wants to ask or something?
There are some questions in the chat. You can see
Let me
and
see.
yeah.
Can't we make whole body of carbon fiber? You can make your whole body with carbon fiber if you can, because carbon fiber is pretty light and pretty durable. But you see, it will cost you a pretty lot, because we can't just make a bend and fold carbon fiber, right? We'll have to make a mold and then form carbon fiber around it. So it will be pretty difficult for us to build the whole plane with carbon fiber. We'll have to make a whole assembly line for us to make a plane using carbon fiber. And what are the real life use
And
cases?
these
Yeah,
are the RC plane. You have like this is for your tinkering part. Okay, you
yeah,
can
yeah.
add anything.
You
Okay,
can add anything,
so
like if you want to bend something or add anything. So I would recommend you to first use some Depro or thermocol or cardboard. Then if you want to, like, carbon fiber, this is, I'm not saying that you can't make a plane out of carbon fiber. Carbon fiber is used in UAVs. The UAVs which military builds, they use carbon fiber body for durability. And like they build large UAVs, like their wingspans comes around like 5 to 6 meters. So they need to use carbon fibers to make the plane durable and uh, good enough to fly. So they will use carbon fiber. But for us, it's we if you want to, you can try, but I don't think it's possible for individuals like us to build a carbon fiber plane. And the second part is, what are the real life use case scenarios or implementations of these RC planes or drones other than photography? Other than photography, you can use these for surveillance purposes. Like you can build something, in you can see there are some there in events you can use these to do crowd monitoring, where you can monitor the crowd from above and direct them. And then you can use these planes for surveillance. As I was saying, military uses them to
and
for surveillance. You can use these for border patrol, to guard our borders, where these planes will fly automatically uh, around our borders, and can you can attach thermal cameras to it to detect any human beings around borders. And then you can also use these RC planes to detect forest fires using implementing AI, where you can set predefined paths where the your plane will fly around forests and then detect fires to inform authorities about wildfires to prevent these fires
and one
before
more
it
thing,
happens.
there are so many applications,
Uh,
and
there is also one use case where you see there are electrical lines, and children, and sometimes via wind, some clothes or some plastic things uh, just get stuck to the electrical lines. I saw a video where a drone had a thrower attached to it. What it was doing is just burning all the like the wires are made up of metal, right? So fire can't do anything. So the drones were using flamethrowers to destroy the foreign objects on the power lines.
so I saw there was like so many emerging technology about these RC plane and drone. Okay, first thing is the delivery part. Okay, I
Yeah, yeah.
remember.
It's also used for delivery, and you can also use these for terrain mapping. The most important part
Yeah,
is,
yeah,
yeah, for mapping your terrain, because satellites are not good enough to map our terrain in high resolution. So you can use these drones to do terrain mapping. For you can use these drones for drone delivery. Uh, yeah, these
in
are some use cases, and there are multiple use cases emerging right now.
in IIT Kanpur, there was open house session, and I was there, and I looked some IIT Kanpur students. They were presenting a plane, uh, which has around 20-kilometer range, I guess. Okay, so that was basically made for delivering the organ or the blood to the hospitals. Okay, uh, because in if we go with the via the road, there will be so much traffic, and it can take so much time. Okay, so we can use drones to deliver all those necessary parts. Okay, so that was one use case, and as I told you, so many. So I don't think you need more clarification on this.
Yeah, if you want to, I can show you guys some videos. Some not. I have a one video of my plane. The actually it's a aerial footage. I can show you that.
Yeah, yeah. Go ahead. After that, I will take the another doubt I just asked. Let me pin it.
Can you see the video?
Yeah, yeah.
This is the aerial footage of my plane. It's actually being recorded by a small camera in the plane. The plane is actually flying around at 50 to 60 kilometers per hour, and this is the footage.
What is the altitude?
It's actually 80 meters, 80 to 100 meters. I don't know.
Great.
So as you can see, for surveillance purposes, planes are pretty good. It's actually flying pretty high. You can fly it at low altitudes for surveillance and tracking vehicles. So actually, I am just giving inputs to the plane, and the wobbling you are seeing right now is the wind that is wobbling the plane. But the flight controller is automatically controlling the plane and stabilizing afterwards. Yeah, that's just it.
Okay. So there is another doubt. Can this technology be used in making underwater vehicles? So basically, in underwater, there is a major problem. Radio wave cannot go underwater. Okay, you have to go with the wired, or you have to use sonars. Okay, that's the major problem. So in submarines or any underwater vehicle is connected with the wire, or it use sonar. Okay, so if you are building some non-military purpose things, so you can use sonar. Or if you want to be like what is called disappear. Oh no, what is called disappear from radar. I don't know. I just forget. Sorry, I okay. So if you want, we don't want to detect, so you can use wired things, okay, and you can use sonar, and you can pre-program your vehicle also. So in IIT Kanpur, I saw some guys building underwater submarine, a toy submarine. So the task was you have to pick three green balls and leaving one red ball, okay. So you have to pre-program it, and you have to add some color sensor and some arms to go underwater and control connect to catch all three green balls and come back. Okay, so that is the main thing you can do in this tinkering part. Okay, and there are so many things you can do with these RC, not RC, uh, underwater things. There are some tunnel mapping thing. Okay, there are some like if you have seen the borewell scene. Okay, in borewell there are some children get fallen, and you have to rescue them. So there are some you have to dig a slant hole along that vertical hole, and you have to capture that boy. So you send a robot to supply some food, water, or oxygen. Okay, so these things you can build. Okay.
Yeah, using a Pixoc flight controller, there is also a firmware for submarines. So you can use these flight controllers also for making your submarine. You can add a Raspberry Pi to it and then a camera to it to do such tasks or automatic tasks.
In underwater, there are a major problem is the communication, and the second problem is the pressure. Okay, the deep you go, the pressure will increase. So you have to make your submarine watertight. Okay, and you like it can bear so huge pressure. Okay, so you have to build it like that. Okay. So if you guys have another some more doubts, you can ask, or we can wrap up. Asad, do you want to add anything?
No, not for not anything.
Okay. Speak, guys. You haven't speak anything till now. You can ask your doubts in the chat also.
Yeah,
Okay.
someone was asking for best places to get all these parts. So please tell them.
Best places. Internet.
Yeah, you can get these parts in online stores such as robo.com, and then
Yeah.
you can just search for these parts. You will get listings on the Google that will get you to their websites, and you can order them direct. You can order these parts from those websites directly. I
Uh,
would not recommend you to buy these parts from Amazon or Flipkart because there are the sellers on Amazon and Flipkarts sell these parts at very high costs. So I would recommend you to buy from authentic electronics online stores. So just it.
and one more thing before ordering anything, make sure that thing is compatible with your requirement, and that is good for you. Okay, I have ordered ESP32 cam module, and I was in hurry. I just ordered without camera module. Okay, there was no camera when I received. Okay, then I in the robo there is no, I guess, a replacement point. Okay, so you cannot return if it is not damaged or not working. Okay, so please be cautious about it, and don't be silly like me. Okay. Okay, if you guys don't have any question, you can tell us about this workshop. You want extension version of this thing in paradox or in upcoming terms, where we will can we can provide you some kits also. You can build it, you can order it, and we will supply it, and you can build it by your own. Okay, so tell me if you want. Okay, no response. Okay, okay, Ajit, let's end this. Thank you, everyone. Thank you, Ajit. Yeah, yeah. So we are planning this thing. Let's see our proposal get accepted or not. If it get accepted, we will make sure we will give you hands-on experience. Yeah, we will. It will like the paradox is around 4 days, I guess. It is, yeah, 4 day. So you can. We can arrange a workshop complete from beginning to end. Ajit, will you be there?
Let's see. I don't have any plans for the paradox right now.
Okay. Okay. So thank you everyone. Let's be stop the recording stream.